Hello, everyone. Thank you for joining us today. Today, we have a session about human parity image analysis with Azure Cognitive Services. My name is Hassam Mohsini. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft partners and the open source community. It's also home to the Microsoft for Startups program. With a diverse mix of hands-on workshops, expert panels, and community events, there's something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our speaker today is Rory Preddy. Rory works in the developer relation team at Microsoft as a senior cloud advocate for Java. Cloud advocates use their deep research skills to help professional cloud developers discover and successfully use Microsoft's platforms. A seasoned speaker whose talks are both meaningful and humorous, Rory travels around the world empowering developers to achieve more. Keep the Q&A tab open during today's session. I'll be sharing some resources, and you can also send us your questions across. That will be where we can interact and answer your questions, and also we'll have regular stops to answer these questions. Rory, you shared an interesting demo yesterday on Twitter, and I really loved how accurate this was. Excited to see more today as you show us more about how this technology works. Off to you, Rory.
Thanks, Azam. Let me just share my screen. And I want to include desktop audio. And let's actually go in, drag Microsoft Teams over there. Great, let's start with our presentation. So Hazem, if you can see me, if there is any issues, just give me a shout. And today we've got a very interesting session, and this is something I've been following pretty much for 3 years now, and it started really on my quest for accessibility. If you've seen some of my talks that I've done before, you'll know that I'm a great advocate for accessibility, and I've been trying to show you how AI can help with accessibility. And recently they've included captioning in Microsoft Word, Microsoft PowerPoint, OneNote, online. And they've really improved the level of detail that captioning has. And I started investigating along with the product team on how they managed to do that. And it was a fascinating journey for me because it also showed me how AI is becoming more astute to be able to do a human being's job than human beings. And I'm going to show you today, and it's some humorous examples also on how you do it. And then I'm going to give you a demo of how you can get started with some Java code. And then I'm going to let you also try it out yourself by forwarding you some tutorials here. So you can follow online. The slides are available on aka.ms/Java-vision. There is also the code example that I put there if you go into the lab section. So aka.ms/Java-vision. You can also follow me on @Rory Preddy, and that's where Hazem said we were having this really funny conversation where we were trying to see whether we could trick the AI with some captioning. So a background to this presentation, in July 2020, Microsoft achieved human captioning parity. And what that means is they signed up for the No Caps challenge that Facebook runs. And the No Caps challenge basically says for novel object captioning, you have to kind of beat the correct score with your AI score. Not only did Microsoft beat it, but it actually became the #1 captioning tool in the No Caps score. Basically, it was the world leader in captioning for imaging. And it beat the actual human being team and reached human parity in July 2020. And what they did is they took all of that information and put it into the Azure Cognitive Services. Every time you call the image captioning Azure Computer Vision captioning service, you're actually using the same tool that they did for the No Caps benchmark. And a little bit of, I'll put a link in there a little bit later in the presentation on where you can go read the seminal paper on how they achieved this, and also the demos. You can see there the Cognitive Services team A background about Microsoft Cognitive Services. It's meant to be easy. It's got REST APIs, few lines of code, flexible, integrated in all languages. I'm going to use Java, but you can use any of the languages, and then obviously tested. So not only is it tested by the researchers, but it's also you'll notice that Hazem was saying that he did a captioning and it was correct, but he also reviewed that caption. And when you reviewed it, it goes back into the model, the computer model, and you help that model become better at what it's doing. So we're going to focus on vision, the Microsoft Cognitive Services vision, and then you've got the API. It's the computer vision API. You've also got the face API. We're going to look at how to use that now. So that's detect, analyze, and tag faces, and it's got a nice little celebrity face section also. Emotion API. I've done many talks on emotion and API. One of them, my famous talk, is sarcasm as a service, where I show how you can teach an AI sarcasm. And then there's the video API, and that's also available in Azure Media Services. So it can go in and analyze and caption and do all of the face, emotion, and computer vision to a streaming video. So for computer vision, and this is what we're going to focus on, there are actually 86 different categories that if you take a picture and you look at all of what's going on in the picture, you have to categorize it in 86 specific types. So you've got object, abstract, scene, outdoor, building, people, animal, text, plant, and each one of them also have subcategories that you have to do. So it's a pretty complicated process. On top of that, also, you need to do computer vision. So you need to tag clip art, line drawings, black and white, is adult, is racy, categories, and then also tag the emotions, and then also the face. So it's a pretty daunting experience though. But so how do you generate textually descriptive sentences that are both accurate and fluent? So here you've got actual pictures. So you can see there's a motorbike, a person riding a motorcycle on a dirt road, two dogs playing on the grass, a group of young people playing a game of frisbee, two hockey players are fighting over the puck. Because if you do this with a human being, you actually get the incorrect result many times, because human beings are also subjective. They're not objective. They won't tell you exactly what it is, because in their mind, with their memories and their emotions, they're going to tell you what they see. They're not what the computer sees. So let's have a look at some examples. And I've got also some examples of what happened with our API. So not only the correct results, but what we did in our previous version of our API. So here's an image and understanding, and let's see what the human being will say and then what a computer will say. And this is using the new API. So a computer will say, boy riding on a horse. Now let's take that same example and do a Turing test. And if you don't know Turing, Alan Turing said that if you want to improve the intelligence of a computer, then a computer should be able to simulate a computer. I know that sounds a little bit confusing though, but a Turing test really is you don't know whether you're speaking to a human or a computer, because it's so accurate. So here's a person, I think that's Nadal playing, it's a tennis. So, and which one do you think is the computer and which one do you think is the human that actually did it? So the first one is a man standing on a tennis court holding a racket. The second one is a man is on the tennis court playing a game. And you wouldn't believe it, but the first one is actually the Cognitive Vision API, and the second one was one that was created by a human. So you're kind of seeing why and how it can become pretty inaccurate, because if you didn't know tennis, and tennis is a localized sport, it's not universally known to everyone, they might not know that that is tennis. Also, you might not know that that's a racket. Let's do another one, a kitchen. So an ornate kitchen is designed with rustic wooden parts, or a kitchen with a wooden cabinets and a sink. So which one do you think is the computer and which one is the human? The first one is a human. Now the human is actually saying rustic wooden parts because that means a lot to them. The fact is that the wood is more important than that. The kitchen means that they're going to be subjective and also really focus on the rustic wooden parts. Whereas the computer is going to say a kitchen with wooden cabinets and a sink, which is much more accurate in describing. Another one, playing in a park, it looks like a fountain. A little girl in a pink skirt standing near a blue metal sculpture. That doesn't sound right. A group of young people playing soccer in a city street. Is there a soccer ball there? Yes, I think there is a soccer ball. Don't know if there's a soccer ball. Let's see which one is that. Okay, so the little girl in a pink skirt standing near a blue metal structure, that's the human. A group of people playing soccer in a city street. Okay, I don't know if there's a soccer ball there. There might be. I see a helmet, but I don't see a soccer ball. I think this is a cycling. So it does get it wrong sometimes. Let's see now also in this video how we went from our first API of our computer vision and how we changed it. And we noticed the subtle nuances and improvements. So you'll see there, the first example is going to be what was before. And then now with the image captioning, with the no-cap additions, what is now. And I'm not going to speak over this, and there's some nice music. And what you'll notice there, that what we just saw, is that the language really matched the image. And I'm going to show you how we managed to do that, because and Hazem and I were having a discussion around this. Now, when AI first was created, you'd have an image of a dog, and it would say dog. And but there's human language involved in that also, and it needs to be a descriptive example of the human language version. If you do hear my children, you know, are they my children? Yeah, you're just gonna have to excuse them. So let's look at so how did you do it? How did we do that? So language generation. So they created a Markov model trained on captions, not text, conditional words detected from images, so typical words. Then they did image analysis and deep learned features applied to the likely image objects in the image, trained to produce words and captions. And finally, they re-ranked it, hypothetical captions re-ranked by deep learning models looking at an entire image. They also did review. So like Hazem did in the beginning of the Twitter conversation I had with him, he reviewed the actual caption to make sure that there was some final quality control. So this is a nice little animation of what that actually does. You have your visual vocabulary and you build a cloud of that visual vocabulary. And then from that visual vocabulary, you go and you fine tune it to the actual image. And then you use inference to, I'll just pause it again there. Finally, you do inference on the final image there. What this is called Azure Florence, a brand new technology that is being rolled out into, let's go back there a second. How do I pause that? This is what happens when you try to pause a GIF. But Azure Florence, you can see here, Azure Florence vision and language. So Azure Florence is a new technology that really pairs vision and language together to give you a descriptive view of and an inference of the language and the caption. Now you know that this is coming to your Word and PowerPoint. It is going to be rolled out though, and this is a really exciting thing. But you can get it right now with Azure Cognitive Services. So of course I took my favorite three Okies, Satya Nadella, Bill Gates, and Steve Ballmer, chucked them into an image there. I don't know who the other gentleman on the left is there, but I wanted to see what exactly is it going to say to me on that captioning. This is the Azure Cognitive Services Image API, and it says there, Satya Nadella, Bill Gates, Steve Ballmer posing for a photo. So not only did it know those people, but it also understood that they were posing for a photo, and that was the context, the language of what they were doing at that moment. It also gives you, if there's multiple options, a confidence level onto what, if you're not happy with that, to go to the next level of confidence in that captioning. So I've got a demo for you. So the first demo I'm going to show you is the Caption Bot.ai. You can go play with it now, right now. It sometimes gives hilarious results and sometimes so accurate results that Hazem and I were discussing around this. It will blow your mind at how an AI can do that. And then we're going to go to the Java SDK on how to get started programming. Okay, so this is Azure Florence, vision and language, and it's got all of the examples. We're going to go through the demo now. We've got the publications. You can go and get the seminal publications there, some videos, some groups, news and features, related services and apps. It'll give you a nice little Python demo. We're going to go through the Java demo and then the web demo. So let's go upload a photo here. So this is the cognitive bot, the caption bot. We're going to upload the same photo that we did with the celebrities. So celebrities there, the Bill Gates and Steve Ballmer. It's going to analyze the image there, and that's Azure Cognitive Services running in the background. And then it's going to give you, I think it's Steve Ballmer, Satya Nadella, and Bill Gates. And then they've even improved it et al. Because they didn't manage to categorize who that person was or posing for a picture. So it's even improved since I actually did it on the Cognitive Services. And then once you do that, then you can say, yes, you did well. And that's going to feed back into the original AI model to make sure that it gets better. So you can try another. It is the captionbot.ai and tweet back on me and see what you enjoyed. So let's go back now to the Java SDK. You can go to Azure Samples, so github.com, Azure-Samples, Cognitive Service, quickstart-code, and then you can go into the, I'm going to the Java version of the computer vision. What you do first, obviously, is you go create a cognitive service here, and I've got my my vision cognitive service here. It's pretty simple to create vision, and I called it vision RPZA, and I'll show you how to actually go in and create that. So let's go into create a resource, and I want to put in there a vision. And I'm going to go computer vision. We're going to go create. And I'm going to create this new, I'm going to call this reactor RPZA. And I'm going to create it into the US West 2 region. And I'm going to call this reactor, the actual instance name RPZA. The pricing tier, you get a free tier, which is really awesome. 20 calls per minute, 5,000 calls per month. You also get the standard S1, which is 10 calls per second. I'm going to do 10 calls per second. You can tag it there, and then I'm just going to go create. And that's how you create it. And I've already created one, so we don't have to really wait. And that's going to, that's going to create in the background when it comes back. So let's go back into our computer vision and see exactly the one that I did create already. And I've called this vision RPZA, Rory Preddy ZA. And you get your keys. So I've got my keys and my endpoints that I've got here. You take your key there and your endpoint, and really you just call the Java SDK. So let's see how we do that with our nice little demo. So I've got the computer vision quick start there, and I've kind of cut it down a little bit there. I've got my key. So my subscription key and my endpoint here. And we've got two little demos. We're going to analyze a remote image, and then we're going to recognize some text, because the same computer vision that you do can actually do more than just image captioning. It can do text recognition, celebrities, other analysis. So we've got our analyze. Let's make this bigger. Boo, boo, boo. And we want to make that smaller. So we've got our image here. So let's look at the analyze remote image here. So I've got my analyze remote image. Now what I've got here is I've got the celebrities, the same one that we saw there with Balmer, Gates, and Nadal. You go features to extract from remote, and now you can add all of these features here. So not only will it give you captioning, but you can also extract the description, the categories, the tags, the faces, the adult. Now, adult means racy images. So what they want to do also, and they give you the ability to sanitize images. So if an image contains a nudity or racism or violence, you don't want to show that on your news feed. And it can actually give you a score to say this actually contains adult material, and you'll remove it from your news feed or your website. The color and also the image type. So then it'll do analysis, and you actually go in, analyze your image with the URL, with those visual features, and it's just going to print out the caption for those captions, the categories, the tags, the faces, and the racy content, the adult. I don't think there's anything racy about Satya. Sorry, Satya, if you're listening. The color schemes, and then also celebrities. The landmarks is pretty nifty also, so you can actually see landmarks images, image types, clip art, line drawings. And then after that, we're going to go recognize text OCR, so printed text, and that's going to take an image of a crumpled up newspaper. Yeah, I know. Crumpled up newspaper, and also the back of it looks like a cereal box, and see if we can read it. And I'll show you what that looks like now. So recognizing text language, text angle, orientation, and it's going to give you the word with the bounding boxes. And let's just go look at that image, the actual image, what it looks like, so you can kind of get a feel. This is a really difficult task. So let's go here, and you'll see here, this is the actual image that we're going to, let's go copy, and let's go back into here. Where's Microsoft Chrome? I want to make that, there we go. Oh no, Chrome, come back. Chrome. Okay, let's go Microsoft Edge. If you want to play funny, if Chrome ever plays funny with me, I go into Microsoft Edge. Okay, let's go there. Okay, there we go. Chrome did come right, and then that's the image that we're going to actually do. And you can see it's a pretty difficult image. And nutritional facts, amount per serving. I'm not too sure what kind of food here. It says 1 bar, so I'm guessing this is a candy bar. Vitamin A, ooh, a very, very fattening candy bar. Lots of fat in that, eh? So, and then we're going to run the image. We're going to run that there, and we should see some very positive results around the captioning and via our subscription. So let's make this bigger. We're just going to hit run here and run current debug file. It's going to go in and get our subscription key. It's a plain old Java object, analyzing the image from the URL. And that's it. That's how quick it is. Remember, this is a really strong server that's going to do. Let's go look back there. Remember the image with Bill Gates here. So caption, Steve Ballmer, Satya Nadal, Bill Gates et al. Are posing for a picture with confidence. And the confidence, I think, is measured at 0.5. So that's pretty high in this regard. So that's a pretty high confidence. Categories, others, outdoor, people groups. So it's got other categories there if you want to look at it. And then tags, person, it knows it's got a person, clothing, smile, black and white image, man, outdoor, posting, human face, suit, clothes. So all of these are those really high confidence, except for clothes. It doesn't know whether they're wearing clothes. Male, male of age 54, 56, 48, and 58. You must know this is incredibly accurate because that's their actual age. Adult is racy content, false with the confidence, and that's a really high confidence there. Has racy content, false. So you can kind of be sure that if you do need to specify that you don't want any adult images, it can do that. Color scheme is black and white, accent color, dominant color, which is great. Celebrities, and you've got Steve Ballmer, and with confidence levels. Landmarks, doesn't have any landmarks. Printed text, so now we're on to the next demo. Printed text, and you can see there, language, English, text angle, orientation up. First word is nutrition and bounded box, but it couldn't actually find all of the text, you can see there it's cut off calories, because in the actual image, if you remember, it doesn't actually have the C. So it's pretty accurate there. And then, yeah, so it got everything exactly right for that. So go play around with the SDK. It's got a lot of examples. If you don't want to do it in Java, it's also got in nearly every other language. It's got in JavaScript, PHP, Ruby, .NET, Krill, PHP, C++, all the languages that the examples exactly the same there. If you want to start incorporating that in your underlying AI programs. Let's go back to our PowerPoint and demo done. So bringing it all together. So why is this so important? Because as an accessibility advocate, I also care about the ability to use AI in everyday challenges. And this was created, this idea behind captions was a novel idea in 2016, which has really come to fruition with the human parity captioning, and really created as part of the AI team that we have for accessibility, as you can see in this coming video.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives. And one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do, but artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
So in summary, why Microsoft Cognitive Services? You've seen how easy it is to actually adopt and start coding with it, and the flexibility around the confidence levels and some of the scoring and the level of detail that it brings you, and then quality. But more importantly, it fits in with Microsoft's vision to empower everyone in every organization to achieve more, and also my personal goal to drive accessibility. So if you want to know more, you can go to aka.ms/java-vision. I'm going to leave the screen, the QR code there. It's the end of the presentation. Hazem, if we've got any questions, I'm also available on Twitter. My DMs are open, and you can follow me. Tweet your image captions, both good and bad. Feedback to the actual product team there. Review those images, and it would be great to see you on the Twitter sphere. So let's take your questions.
Right, I would like to encourage the community to engage on Twitter and try and test how things are working there. Post some pictures, engage with Rory at Rory Preddy. That will be fun to see where you see when you get like accurate or non-accurate results, and you can fool the AI. I think you've got some interesting examples over there that happened to be not so accurate, I would say.
Great. Thanks, Hazem. Thanks for the time today. You can also reach the questions on Twitter. And then, it's a great opportunity to speak at WW Reactor. Thank you very much.
All right, then if that was it for today, let's give it some time for some questions, and I would like you to highlight some of the 2 upcoming talks. I will start sharing my screen now. That will be interesting to share with the community. We're doing 2 more this month with Rory. I'd love you to share some of insights into what we're gonna talk about on these sessions. Sharing my screen right now. Okay, just a second. All right, I think, yeah, I got that. So yeah, your session on next week on November 10th, maybe you can tell us more about what we're gonna talk about on that session.
Yeah, no, that's an interesting session. So we recently launched JBoss on EAP on app services, and I'm a big JBoss fan. And if you must know, JBoss is one of the most popular application servers for Java and Java EE. And we've got a really nice app service offering that allows you to deploy, and there's a free tier offering also. Deploy your favorite JBoss app and your Java EE app there. And what I'm going to do in that session is one of the infamous Microsoft interview questions is to pick a number. So you say, I'm thinking about a number, you get 20 guesses and between 1 and 100. And what our ex-CEO used to do, he says, you've got only 5 tries, and every try you lose $1. I'm going to give you $5, and now would you take this challenge? I'm going to show you how the AI works a little bit, and then we're gonna deploy that to and show you the ease of use of deploying it to the Azure App Service, the JBoss app, and then also scaling and really handling a lot of the enterprise production requirements for a Java EE app.
That will be great, and we will have you again as well towards the end of the month to speak about Terraform. So also tell us more about this one.
This is mind-blowing. So if you know, I don't know if you know about Terraform, but it's infrastructure as a service. So how many times do you have to spin up and spin down and tear up your systems? And all you really want is just one button to click, and Terraform is the industry leader of being able to do that. You can script out all of your infrastructure, all of your backing services, all of your your code as a service, and it's painless and so quick and so elegant, and it ties really great. We're a partner with the Terraform HashiCorp organization. It's incredible to watch that you can build an entire ecosystem with one click in one go.
That will be great. All right, looking forward to it. I'll share these links in the Q&A tab for everyone to join. Make sure you join us on meetup.com. All these sessions will be posted there. I'll also highlight more of the upcoming sessions. Maybe also you'll find more interesting topics. There are some workshops on building web apps, Azure Landing Zone, Xamarin, some topics in data science and machine learning as well, and DevOps. You can check out the full calendar on meetup.com /the Reactor Abu Dhabi. Don't forget that we're doing the survey for the sessions. You can send us some feedback on everything you would love to see at the reactor, the topics in terms of web development, AI, machine learning, and so on, and use the session code for today's session. It's 12300. That will be on that form. So just spend a minute or two to send us some feedback. Don't forget to be part of the meetup if you're not already. Join us on Twitter. The hashtag is Reactor Abu Dhabi and MSFT Reactor is the Twitter handle. This session will be posted on the YouTube channel that we have on Microsoft Reactor. So subscribe to that channel and you will find this content on demand. We also send a monthly curated newsletter, and you can be part of that newsletter by checking and filling the link on the Reactor email sign up. That's all for today. Thank you again for joining us, and thank you, Rory, for always sharing your expertise with our community. We are excited to have you next week doing the more sessions also later this month. We have 2 more, and it will be great topics to discuss.
Thanks, Hassan.
Thank you, everyone, and goodbye.